The Boeing 747 has nearly disappeared from passenger service worldwide. Yet that distinctive curved hump above the cockpit remains one of the most recognized profiles in aviation history. Most travelers assume the upper deck was designed as a luxury lounge or a premium cabin innovation. The actual reason Boeing engineered that hump in the 1960s had almost nothing to do with passengers. Here is what the 747 hump was really for. The story begins in 1966. Boeing committed to building an aircraft roughly twice the size of anything then flying. The decision was not driven by passenger demand. It was driven by an industry assumption that turned out to be completely wrong. Boeing engineers in the mid-1960s genuinely believed that supersonic commercial travel would render conventional subsonic jets obsolete within a decade. The Concorde program was advancing in Europe. The American Supersonic Transport Program was funded and underway. The conventional widebody, in the prevailing industry view, had a limited future as a long-term passenger platform. That single assumption shaped the entire 747 program. Boeing designed the aircraft primarily as a future cargo platform, with the expectation that within a few years, its passenger configuration would be converted to freighter duty as the supersonic era arrived. Every major design decision flowed from that expectation. The cargo requirement is what created the hump. A wide-body freighter has to load oversized cargo through the nose. That meant the entire nose section had to swing open vertically on a hinge. That meant the flight deck could not sit at the front of the main deck like every previous Boeing jet. The cockpit had to be moved up and back, elevated above the loading path so that the nose could pivot upward without disturbing the controls or the crew positions. That single engineering requirement is why the 747 has a hump. The upper deck was not designed as a passenger lounge. It was a structural enclosure to house an elevated cockpit positioned high enough that the nose of the aircraft could swing open beneath it for freight loading. The aircraft's chief engineer, Joe Sutter, had originally proposed something entirely different. Sutter wanted a true double-decker layout, 2 full passenger decks running the entire length of the fuselage. The configuration would have shortened the overall aircraft, improved ground handling, and maximized total seat count for the same wingspan. On paper, the design was an efficient solution for high-volume passenger operations. FAA safety regulations killed the concept. Every commercial aircraft certified for passenger service has to demonstrate full evacuation within 90 seconds with half the emergency exits blocked. Engineers calculated that evacuating 2 full passenger decks through the available exit configuration was effectively impossible inside that 90-second window. The double-decker concept was scrapped. The compromise was the partial upper deck. The front section retained the elevated structure required for the nose-loading cargo configuration. The remainder of the fuselage reverted to single-deck operation. What began as a regulatory compromise inadvertently created the most recognizable silhouette in commercial aviation history. The supersonic replacement plan never had to be executed in the way Boeing originally expected. Supersonic commercial travel never replaced subsonic widebodies. The Concorde entered limited service in 1976 and was retired in 2003. The American supersonic transport was canceled in 1971 before any prototype flew. The 747 ended up operating as a passenger aircraft for over 5 decades. The cargo capability built into the design proved enormously valuable anyway. When passenger 747s reached the end of their commercial life, airlines converted them to dedicated freighters. The nose-loading capability that justified the entire upper deck structure became the defining feature of the 747F family. Aircraft that started life carrying business travelers across the Pacific finished it carrying automotive parts, satellites, and oversized industrial machinery across the same routes. The 747's role evolved further in unexpected directions. NASA selected modified 747s to serve as shuttle carrier aircraft. Engineers reinforced the fuselage structure and added vertical stabilizers to the tail to compensate for the aerodynamic interference caused by the shuttle riding on top. Those modified 747s completed 87 ferry flights, transporting Discovery, Atlantis, and Endeavour between landing and launch sites. The final shuttle ferry flight took place in 2012. When Endeavour was delivered to Los Angeles for museum display. The same airframe also outperformed nearly every modern jet on raw speed. The 740, 7400, and 740-78 cruise at Mach 0.85, equivalent to roughly 564 miles per hour at altitude. Most current widebodies cruise around Mach 0.80. The speed difference is small per sector but compounds across transoceanic operations. In February 2020, a British Airways 747 caught a powerful jet stream over the North Atlantic and completed a New York to London crossing in 4 hours and 56 minutes. That figure shattered the previous subsonic record and approached the cruise speed of the retired Concorde. The aircraft's capacity proved adaptable in extraordinary circumstances. In May 1991, El Al stripped a 747-400 of most interior furnishings during Operation Solomon, the Israeli airlift of Ethiopian Jews during the country's civil war. A single aircraft carried 1,088 passengers on one flight, more than double normal capacity. That figure remains the record for the largest number of people ever transported on a single commercial flight. 2 women gave birth during the journey, so the actual passenger count on arrival exceeded the figure at departure. The original 747 cockpit reflected the era it was built in. The flight deck contained 971 individual switches, gauges, and indicators. A 3-person crew operated every long-haul flight. The pilot and co-pilot handled controls. A dedicated flight engineer managed fuel transfer, electrical generation, cabin pressurization, and environmental control systems. The glass cockpit avionics introduced on the 740-7400 eliminated the flight engineer role in 1989. The original gamble nearly destroyed Boeing as a company. The 747 required over 6 million individual parts, 171 miles of wiring, 5 miles of tubing, and 75,000 engineering drawings. No existing facility could house the assembly. Boeing built the Everett factory in Washington State specifically for the program. At 398,000 square meters, it remains the largest building by volume in the world. Total development costs exceeded $1 billion in 1960s dollars, equivalent to roughly $9 billion today. The figure exceeded Boeing's entire net worth at the time. The engineering and assembly team that delivered the aircraft from concept to first flight in 28 months called themselves the Incredibles. As of May 2026, the 747 is effectively gone from scheduled passenger service. The final passenger delivery took place in 2017. The final 747 of any variant, a 740-78 freighter, rolled out of the Everett factory and was delivered to Atlas Air in January 2023, closing the production line after 1,574 aircraft. The type remains in active freighter service across every major continent. The 2 new VC-25B aircraft being built to replace the current Air Force One are derived from the 740-78 airframe. The hump that originated as a structural accommodation for nose-loading cargo will continue carrying United States presidents into the 2030s.